All right, today we're talking about angle relationships. And the first angle relationship we are going to talk about. Screen is frozen. Adjacent angles. Adjacent angles, they're next to each other. They share a side. And vertex. Would look like this. Angle ABC and angle CBD are adjacent. ABC and CBD are adjacent. They both have side BC, and they both have vertex B. So they meet the definition. Next to each other, share a side and a vertex. Adjacent angles. Next set. Linear pair. A linear pair of angles are adjacent and form a line. A linear pair of angles, they are adjacent and form a line. Their sum is 180 degrees. So if you draw a straight line, put a point on it, and draw a ray out of that point. Let's go with M, N, O, and P. And we're going to say angle MNP, green, if green will come up. Angle MNP and angle ONP form a linear pair. So MNP and ONP form a linear pair. They meet the rules of adjacent, they form a line. So if I tell you green angle is 130 degrees, what's the measure of blue angle? Everybody should have their calculator on their desk with all their highlighters that I can hear opening and closing. And I just told you that their sum is 180 degrees. So if one of them is 130, please get involved and tell me what the blue angle measure is. Yes, thank you very much. 50 degrees. Vertical angles. They are formed by two lines. And opposite of each other. Their measures are congruent. Vertical angles, they're formed by two lines and opposite of each other. Their measures are congruent. Line L, line M intersects at point A. In this diagram, we have two pairs of vertical angles. One pair would be angle BAC and DAE. BAC and DAE are congruent to each other. They have the same angle measure, formed by two lines. They're opposite of each other. The other pair in this picture BAD and CAE are the other pair of vertical angles. So here's the symbol for them being congruent. Two arc marks on BAD and then two arc marks on CAE. Top angle congruent to bottom angle. Green congruent to green. Blue congruent to blue. They are vertical angles formed by two lines. Their measures are congruent. Complementary angles. Any two angles that sum 100, nope, God, can't believe I said that. That sum 90 degrees. Complementary angles. That's any two angles that sum 90 degrees. So one example, if you draw a 90-degree angle, and now this angle isn't 90 degrees until we put the 90-degree symbol in there. Now it's 90 degrees. Now if you put your pencil on point B and you take a ray out of B anywhere up and to the right, you just formed complementary angles. Since the original angle ABC was 90 degrees, ABD and DBC have to sum 90 degrees. Because ray BD was in the interior of that angle. So if green angle, ABD, computer's a little slow today, measures 50 degrees, then the measure of angle DBC would be 40 degrees. All right, so green and blue are complementary. Now, they don't have to be adjacent. If angle X right here is 60 degrees and angle Y right here is 30 degrees, then those two angles are complementary. They don't have to be touching each other. They don't have to be adjacent. They don't have to share a vertex. They just have to sum 90 degrees. Supplementary angles. Any two angles that sum 180 degrees. Supplementary angles, any two angles that sum 180. So back to this straight line with point A on it, and you run a ray out of A, blue angle, and green angle, they are supplementary. You don't need any angle measures on here to see that they're supplementary, because the two angles next to each other, they're a linear pair. All right, they fall under the linear pair category. They're adjacent and they sum 180. That makes them supplementary. So if over here on the left we got a 40-degree angle, if blue is 40, what's green? 140. They're supplementary. They sum 180. Their non-common side forms a straight line. Now, you can also have a supplementary pair of angles that don't touch each other. So you could just have an angle M right here that's 10 degrees. And then you could have another angle P, that's 170 degrees. And those two angles are supplementary. Their sum is 180. They don't have to be adjacent. They don't have to be touching each other. All right, so let's do a couple of problems related to these terms. We are going to find the measure of two complementary find a measure of two complementary angles if their difference is 18. The difference in the angles is 18. They're complementary. So here's how you set this up. You're going to be doing this type of a problem all year long. Find the measure of two complementary angles. Two complementary angles. Here's one of the angles plus the other angle has to equal, they're complementary, so what do they got to sum? 90. If the first angle measures x degrees and their difference is 18, difference means to subtract, right? So if the second angle is x minus 18 degrees, Can't we combine like terms now, solve for x, and substitute? That's your setup. In this case, find the measure of two complementary angles if their difference is 18. So it's x plus x minus 18. If it said their sum was 18, what changes? The first angle or the second angle measure? We did x plus x minus 18 because it said difference. If it said their sum is 18, what changes in this formula? Correct. Instead of it being x minus 18, it becomes x plus 18 because sum means to add. So if you combine your like terms, you get 2x minus 18 equals 90. If you add 18 to each side, then 2x equals 90 plus 18. I say 108. So does my calculator. Divide by 2. X equals 54. So there's one of the angles, right? And then the other angle is going to be 54 minus 18, which is 36. So 54 and 36 degrees. Let's do another problem like this, but we're going to use a different term. We're going to find the measure find the measures of two supplementary angles if the larger is 12 more than twice the smaller. So our concept for solving this problem is going to be the same. We've got first angle plus second angle. What do these two have to sum? These two got to sum 180 because they're supplementary. Find the measures of two supplementary angles. So I'm just going to call the first angle the first angle. It's x degrees. The larger one is 12 more than twice the smaller. How do we write twice the smaller if x is the first one? 2x? And how do we write 12 more than that? Plus 12. So here's one angle. Here's an angle that's 12 more than twice its size. We set this equal to 180 because they have to be supplementary. So again, you're going to combine like terms. 2x plus x is 3x plus your 12 equals 180. Subtract 12. And 3x will equal 168. If you divide both sides by 3, one of the angles is 56 degrees. And then to find the second angle, we do 2 times 56 plus 12. $124. So one angle is 54 degrees. The other angle is 120. I'm sorry, 56 degrees and 124. All right, so we've got more material to cover in this section before your quiz on Friday, but you are going to be released today at 11:30 to go to your third block class from last term and pick up your report card. Okay, so we're going to cover perpendicular angles and solving problems related to perpendicular angles tomorrow, and then you'll get your study guide. All right, so for right now, that's all the notes you're taking for today. I'm going to give you some practice to do. It's going to be page, let's see, pages 9 and 10. Let me do it this way. They're going to be, all right. Page 9, 1 through 8. Page 10, 1 through 6. Make sure you're doing it on a clean piece of paper. You're doing it on a clean piece of paper and not in the workbook. Make sure that you show all your work neatly. And upon completion of that, you're going to check focus for any homework problems that may be on there. All right, so e-learners are excused from the meeting if you don't have any questions to complete that assignment. If I don't see or hear any questions in the next short amount of time here, I'm going to end this meeting myself.